Alright, so now we are going to focus on the coordinates of the unit circle. This is exciting because this is the culmination of the unit circle. Kind of. But this is where we're going to see all of the special angles in radians, in degrees, and then the coordinates that go with them. And then later on we're also going to learn why do we care about that. How do we use it? It's going to be special. Alright, so first thing, let's jump into a little refresher. Remember we did this the other day. If I have a 30-degree triangle and a 30, 60, 90 triangle, remember I can label the sides. This is x, this is 2x, and this is x root 3. This is going to be important for today. And then also, if I have my 45, 90 triangle, then this is going to be x, x, and x root 2. So we looked at those the other day, and that's going to come back. It should make sense because we know, remember, all of the reference angles in degrees are either 30, 45, or 60 on the unit circle. So if we look at our unit circle, what we're going to do is we're going to focus on the first quadrant. The first quadrant is crucially important. Just like with the angles in both radians or degrees, if you know the first quadrant, and you know a little bit of other knowledge, like reference angles and just some other stuff, you can find all of the other angles on the unit circle. The same is true with the coordinates. If you understand the coordinates in the first quadrant, those are the same coordinates all around the circle at the same special angles because they have the same reference angles. So what we're going to do here is we're going to draw a triangle. So if I look at the first segment here, if I make my right triangle here, I know that this angle here is 30 degrees, right? And now what else I know is because this is the unit circle, what was the definition of the unit circle? The definition of the unit circle was that there is a radius of 1. So I know the hypotenuse of this triangle here is 1. And so if we go back to looking at this, right? Well, if the hypotenuse 2x, if that equals 1, what does x have to equal? X has to equal 1/2. And then what would x root 3 equal? Well, that would be 1/2 root 3. Right? So that allows me to understand then that if this is 1, this is 1/2, and this is, instead of writing 1/2 root 3, I'm just going to write it as root 3 over 2, but that's the same thing. And now if I think about a coordinate point, well, this right here is representing the x coordinate of this point, right? If I think about how do I get to this point, well, I go over this far and I go up this far. So the coordinate right here, the coordinate point, is root 3 over 2, comma 1/2. Huh. Who knew, right? Okay. Well, we're going to take that same idea, and this is going to get a little clustered. So if I draw this, right, we know that that's 1 also. And this triangle is a 45, 45, 90 triangle. And so just to avoid making a big mess over there, if the x root 2 part, so we're going to say if x root 2 equals 1, then I know x equals 1 over root 2. Or, we have also seen, remember, that this is the same as root 2 over 2. Now, I mentioned the other day, it is not important that you rationalize. However, I would emphasize that especially with the unit circle, a lot of times we see these things rationalized. So I'm going to write it in the root 2 over 2 form. But I know x is root 2 over 2. So this side is root 2 over 2. This side is root 2 over 2. And so if I go back here, if this distance is root 2 over 2, and this distance is root 2 over 2, then that tells me this point has to be the point root 2 over 2, comma, root 2 over 2. And then if I go to the next one, here, this is again just a 30, 60, 90 triangle. It just switched which side is 60 and which side is, where the 60 degree angle is and where the 30 degree angle is. Right? So now we know this angle here is 60. And so this angle here is 30. So all that does is switch the sides of the triangle. So I know that this side right here has to be 1/2, and then the vertical side has to be √3/2 because the hypotenuse is still 1. And again, it's getting kind of messy in here, so I'll just draw that off to the side so you can see it a little better. If this is 60 and this is 30 and that's 90, if I know this is 1, this has to be 1/2 and this has to be √3/2. Right? And so that's this triangle in green here that I tried to draw. Now the other coordinates we didn't talk about yet. Well, what is this point here? Well, if the radius is 1, then, and remember the origin, or I'm sorry, the center of the circle is at the origin, then I know this is the point 1, 0, and this is the point 0, 1. Now, I want you to try to label the rest of the unit circle with the coordinates. And if you understand the stuff I said earlier at the beginning of this video, it should be pretty easy to do, because the triangles, these 3 triangles, aren't going to change. Those are the same 3 triangles in every single quadrant because the reference angles don't change. The only thing that changes is should the x and y coordinates be positive or should they be negative. Alright, pause the video, try to do that. Unpause when you're ready to check. Alright, so here we have our unit circle. We already labeled these coordinates, right? So in the second quadrant, this coordinate should be the exact same as this coordinate here, right? These two are the exact same. The only difference is the x coordinate is negative. Here, these two should be exactly the same because they have the same reference angle, except for the x coordinate's negative. And here, these two should be exactly the same, except for the x coordinate is negative, because I'm in the second quadrant. And then the same is true here, right? If this is 1, 0, this is we're going to call negative 1, 0. Because remember, the negative here is representing a direction. It is not representing a distance. The radius of the circle is always positive 1. But the distance from the origin to this coordinate point is going to be negative 1, because that's the direction. Yeah, that's that x direction. When we move down to the third quadrant and the fourth quadrant, again, these are the same as this as this coordinate point and as this coordinate point, except for in the third quadrant, both the x and the y are negative, and in the fourth quadrant, the x is negative. I'm sorry, the x is positive and the y is negative. These are the same as the other 45 degree reference angles, or pi fourth radian reference angles, except for here the x and y are negative, here the x is positive, the y is negative, and then the 60 degree or pi third reference angles are the same as well. And then down at this coordinate point here, this is the point 0, negative 1. So now we can see here is the entire unit circle with our degrees, our radians, and our coordinates. It is a thing of beauty. I know. Just to give you, a little hint later on, in this class, ideally it'd be great, but it's not expected when you actually get to a trig class. This is going to be something you're going to want to memorize, but remember, it's not about memorizing a bunch of interesting or unique facts. It's about understanding where these numbers come from. And if you think about, as I've been trying to teach this to you, the strategies, understanding the reference angles don't change, understanding how we come up with those coordinate points, it should be less daunting than it might seem when you first look at this circle and all of these numbers. It's not about memorizing it as a bunch of unique, different pieces of information. It's really about understanding it. That's what makes it so special.